And so we have an addition to the schedule. So there's an extra, it's an extra bonus session. We get an extra talk at the end of our session. Matt Waldron from the PADEP will be presenting. So when you're just feeling sad that our session is finishing up, it's your lucky day, you get an extra talk. All right, so we're gonna start off with Chelsey Erickson. She's gonna be talking with us about the USEPA Beaches Act, and she's from the Erie County Department of Health. And so I'll let you get started.
Good afternoon, everybody. Like she said, my name is Chelsey Erickson. I work with the Erie County Department of Health. I am an environmental protection specialist with the county. One of my job duties is overseeing the lab for beach testing at our Great Presque. Just so everybody knows, we are a nationally accredited health department. We got accredited in September of 2014. We were one of the first health departments accredited. So we have measures and things that we have to meet every year, so you know the standard is there. So a lot of people know about the Beaches Act, but they don't know it by name. They know that the health department and DCNR actually work together to test the beaches at Presque. But there's a reason for that, and it's called the Beaches Act. So it stands for the Beach Environmental Assessment and Coastal Health Act, and it was signed into law by President Clinton in 2000. This law is to amend the Clean Water Act of 1972, and what it does, it requires EPA to develop performance criteria for testing, monitoring, and notification of the public of any possible When Congress wrote the bill, they also included appropriation monies for that. That happens a lot with a lot of bills. The monies are to help implement that act. So when they wrote the act, they appropriated $30 million for it. Now, that does not mean that every year we get $30 million for our beaches. We, on average, get about just under $10 million. And we've been getting that money since about 2001 when the act really got going. Over the last few years, it's been anywhere from $9.3 to $9.8 million. And you think, oh, that's a lot of money. And when you look at the yearly total, or the total overall, $167 million has been awarded. You'll see here in a minute why that's not a lot of money. So on this slide, it shows getting just under $10 million to all of these places. So that's, in the grand scheme of things, it ends up not being a lot of money. And to qualify as a Beach Act state, it has to be marine beaches or Great Lake beaches. It does not include inland lakes or inland rivers. So these we apply each year. So this year in 2018, we applied in early summer, late spring. The monies we get awarded in 2018 actually will be used for 2019 beach season. So we're applying for a year ahead dollar amounts. And then what'll happen is at the end of the season, data has to be reported by 2020. To EPA. So it's kind of a longer time frame than just that year. What these grants do will help authorities at the state and local level conduct these monitoring and notifications that are required under the Act. There are three ways that money is awarded, EPA looks at all of these. First one is the length of beach season. It's different for every state. It can be as short as a month as in Alaska, or 6 months or longer like California, Florida, Georgia, South Carolina, where they have a longer beach season. Next one they look at is the population of the county that's hosting the beach. So a lot of people would hope that it's the people that are visiting our beaches, but it's not. It's actually the resident population of that county the beach is in. And then finally, what they also look at is shoreline miles of the county. So how long is the actual shoreline for that? So you're thinking, well, if states are doing it, why is Erie County actually involved in the beach? Over the years since then, this protocol has been updated to include additional partners, and even as recently for predictive models. Some of our partners include the Regional Science Consortium, USGS, and Penn State Barron. And USGS and Penn State Barron help us with our predictive models. One of the requirements universities and other agencies. And they decided, well, it's time. We need everybody to be on the same page. There is some new data out there, so this is the updated criteria that we're all working under now. Criteria doesn't mean regulations. Criteria is just a guideline. The states, if they want to, they can enact this criteria at a state level and make it part of their regulations to move forward with beaches. Some of the recommendations that have been included is the use of predictive models. It wasn't widely used that predictive models were used or even thought of. A lot of states and quite a few beaches now are only using predictive models to notify the public of beach issues. Before it was fecal coliform as an indicator of bacteria, and what that is it's a bacteria that we can test for fairly easily. It's not an expensive test to test for, and tells us that something's going on, that there's the potential for pathogenic bacteria in the water. EPA asked that for Great Lakes, we go with E. coli. They also asked that we use approved standardized testing methods. They said you could use a beach action value to notify the public. So that number that you hear when their beaches are closed, then they say it's at X number. We're using a number to determine whether or not it should be closed or not. Rapid testing methods are now like the big push. Most testing methods we use is a 18 to 24-hour turnaround time. Some of these testing methods that are rapid are a 3 to 5 hour turnaround time. They're getting more popular. The problem is with Great Lakes, there's no standard method on that rapid testing for E. coli. For marine waters, there's a standard method and they are using it more often. Another thing would be using sanitary surveys. So going out and collecting more information when you collect the sample. Are you getting weather data? Is there birds? Is there swimmers? Is there trash? And then on an annual basis, go back and look at all of that daily data and then look at the overall beach itself and use that sanitary survey to see where improvements can be. One of the other things that EPA did for us is they created tools. So they gave us apps, they gave us the surveys, they gave us direction on how we can evaluate our beaches and then manage our beaches effectively. So, we use E. coli as an indicator bacteria, and that's the most common one in the area. And we also use the testing method that's approved for EPA. One of the other things that we do is we rank all of our beaches that we oversee on a scale of 1 to 4, 1 being highest use, highest risk, to 4 being we're not using it right at the moment for swimming. Like I said, E. coli is a cheaper method. It's pretty inexpensive. It can take, once everything's said and done, it can take about 20 to 24 hours to get a turnaround time. The other thing is E. coli you can see with animal waste, human waste, just general environment from storm runoff too. So what do we do? They go collect the samples. So that's some of the monitoring. So the testing is this. That's one of our interns from this past year. And the interns go out at a minimum Sunday and Monday. Depending on if samples are bad, they could go out 7 days a week. So what they do is they'll put on their waders, they go out into the water about between knee and waist high. They open up their jar, they stick it down to their elbow, and they get a little bottle of water. And each beach, except for one, has 3 sample sites. So they're going in 3 different times at essentially 12 beaches. So they'll collect that water, they get us weather data, some other environmental data. Is there debris on the beach? Is there algae? Is there dogs? Is there gulls? Are there geese? How many people are on the beach? How many people are in the water? So that's information that we can use to crunch data later on. Now, Freeport Beach, this is a little odd. Wastewater treatment plant employees actually go out and collect those samples for us. They have 1 beach, so they have 3 sites. Basically, the sites are each end and right in the middle. Surprisingly, with Freeport Beach, they are right at the outfall of their sewage treatment plant. I believe it's 16 Mile Creek. The sewage treatment plant dumps into 16 Mile Creek, and it's right to the west of the beach. But Freeport Beach doesn't have a lot of issues, if any issues at all. So that shows you the water coming out of the sewage treatment plant is actually pretty clean. So interns bring the and we used a vacuum pump. We put a funnel on, and between everything there's this little piece of paper, like cellulose paper. we put the water through, and we turn the vacuum on, and we pull the water through that vacuum. And what's left behind is the bacteria on that filter. So water doesn't stay, but anything that could be harmful to people is going to stay on that filter. So they run all the samples, and then what happens is we put them in a dry incubator for 2 hours. It's kind of a recovery. Like they're taking a nap, they got to recover, because we want the bacteria that's alive to grow so we can count it. After 2 hours, I put it in a water bath. And that's at about 45 degrees Celsius. So it's pretty hot. Not so hot you can't put your hand in, but it's warm enough that that bacteria is going to grow. It's going to be happy for that time frame. After 22 to 24 hours, we will pull out those plates. And because the bacteria stayed on that paper, and it's on a plate, and what happens is we put it on an agar, which is kind of this growth medium. So not only is it happy, the medium allows for that extra growth, but we don't enumerate or count it at all. So you're thinking, how do I translate that plate into the advisories you see on Presque? So we use the computer and a counter. So we don't have to count it by hand. A lot of people who are old enough in here to know, we used to do it by hand. We take it and we grid it off and we count them individually. I have a computer program and a machine that does that, so I don't have to worry about it. And it does my math for us too. Rose will tell you how nice that is. So we use probably 10 or 25 milliliters. So we have to put that into the machine so it gives us the right number for 100 milliliters of water. Does the math and everything, we count everything. And in the bottom right-hand corner, you can see where it's at. There's only 3 on there. So that's 3 colony, we call them colony forming units. So 3 colony forming units on there. So when all's said and done, we get numbers. Well, that's testing. The next step is actually we get to monitor the notification. That's taking what we're seeing here to tell you guys out in the public what it is. So we in Erie County, to advise the public, we're using a 2-tiered system. So there's the advisories everybody's heard about, and the restrictions I'm sure some of you have heard about probably this year. This was adopted based on a protocol that was implemented in Racine, Wisconsin. Actually, quite a few Great Lakes states or Great Lake beaches are using this 2-tiered system, where it's saying that an advisory is, well, if you have certain things going on, you may not want to swim. A restriction is we definitely don't want you to swim. Now those predictive models and the research plate counts that the Science Consortium does every day, the park manager uses that information to do what we call precautionary advisories. That's when we at the health department and our interns and myself are not running those samples. Because there are some times where things are good on our end, but there may not be good on the predictive model, or a couple days later, the Science Consortium's plates are coming back bad. So the managers are using this as another way to kind of help advise the public that there is a potential risk and you should be informed about it. So those advisory numbers, in those, one of those categories, when you get sick from E. coli, it's a lot worse than if you're a healthy adult. A restriction is anything over 1,000. We're saying, doesn't matter who you are, how healthy you are, we don't want you in the water. The nice thing is you can still go to the beach, you can still sunbathe, you can still play volleyball. We're not restricting you from the beach, we're just restricting you from the water. That's because we just don't want anybody to get sick. So, that's a lot of ways. And you think, oh, why do we need any more? Well, we at the health department also advised you on our website as to what's going on. The problem was, this is what very user-friendly. So I took it upon myself to say, how can we do this better? This is a requirement we have with the grant. We have to show that at our end-of-year reports. We have to show the government, the EPA, that we are notifying people. And one of the things that they really recommended in that criteria is using social media. I can't use this on social media. I can't use this on Facebook. I can't use this on Twitter real well. So, and don't even get me started on how this looked on a phone. I tried to look at this on a phone. It didn't work. So, over the course of the beginning of the year, since about January to early May, I worked on researching other states. Since I have access to all the other states as being a coordinator with the EPA grant, I was able to see, just like you are, what other states are doing. Are they using maps? Are they using something like this? Are they using lists? So after a culmination, we got a new way to notify you and the public. And on May 25th this year, it launched on the Science Consortium's website, and it launched on ours. And this is what quite a few are using lists through a PDF, and that's becoming very antiquated too. And it's just not as good as seeing it in this type of format. So I went to, when I came across the Commonwealth of Virginia, State of Louisiana, and LA County, California, they're all using Google Maps. They're all using the free version of Google Maps, because if you go on and look at theirs, it's very similar to this. So I took that and I'm like, well, if it's free, we can use it. It's something that can be easily updated, doesn't take very long to do on the back end for our purposes. And I can include HAB information as well. Virginia has 2 separate maps. California has 2 separate maps. That's fine, they have bigger areas of coastline to deal with. We have this coastline, so I also decided that, and with talking with other people, it's easier if we combine it, because people come to Presque, they want to know what's going on all around, not just with swimming beaches, but with HABs too. So, let's see if I can do it. So when you click this, maybe it'll go. So this goes directly to, so this is what it's going to look like on our page. Oops. And you can include. And then you can click, and it tells you what the beach is, the date it was updated. Right now, everything's closed, so there's no sampling. But in the current status, if there was an issue, it would say advisory, restriction, precautionary advisory, precautionary restriction. Description, we don't use description for beaches too much, except to tell you that it's closed, that sampling will begin. For HABs, it's a little bit more descriptive because we have advisories for dogs because of the levels. So I wanted it to be interactive, and when you go on a phone and look at this is great because this is so user-friendly for everybody that it actually exceeded my expectations when I created this. The other thing is since May 25th to today, the map has been viewed over 65,000 times. 65,830 times this map has been viewed. Unfortunately, I can't see where people are viewing it from or which specific sites they're looking at, but this tells you that a lot of people are viewing it. Also, it can be shared on Facebook very, very easily, and I've noticed that when we share this on Facebook, especially in July, we had huge views, upwards of 2,000 views in one day. The last thing is that the federal government is noticing this too. In May and June of this year, EPA produced a freshwater HABs newsletter, and we were, not that it's a good thing, but it's a good thing that it's being used and it's being put out there, that it was in that newsletter as well. So we're getting, people are seeing this not just from Erie County or Pittsburgh or Cleveland, but all over as well. So it's actually ended up being quite user-friendly and quite useful. So this actually helped us do that last little bit of notification requirement. That's my contact information. Most people know where I'm at, and I usually do get the phone calls in the summer if people don't know about the map, that I tell them about the beaches and if they're closed or not. So, any questions?
We actually don't have time.
No? Okay.
We have to move on.
Okay.
Find Chelsey afterwards. All right, so our next speaker is also from the Erie County Department of Health, and it's Mathew Elwell, and he'll be speaking about small flow treatment facilities here in Erie County.
A little bit more excitement. We're going to be talking a little bit about poopy. So we're looking at small flow treatment facilities in Erie County. I got to figure this out real quick before we go. There we go. Region. So we're looking at, it's an individual or community sewage system designed to only be 2,000 gallons or less. Now we really have 3 choices on sewerage in Erie County. First is, if you have public sewer, you have to hook up the public sewer. So you flush the toilet, you don't think about it, it goes to your community system, and it's gone. The other two systems are, if you have soils that are conducive, you'll have probably what's called an on-lot septic system. If you don't have the soils conducive, then what you have is a small flow treatment facility. If you have a drainage swale or some type of creek where it can outfall to, the soils will not accept the waters of the sewage so that it doesn't naturally dissipate through there. So those are kind of your three choices. Your last choice is a small flow treatment facility. That is if your soils are not good, but you have that drainage swale. Treatment methods and new technology. The traditional is the old sand filter. So what do? Is they recreate out. It naturally goes through the sand filter and goes out. The biofilters, we used to use peat. We don't find peat moss anymore. So what we have is coconut husks. That's been the new technology that's using with that. And actually the things that kind of clean your sewage attaches to that coconut husk. And as the water goes through it, it feeds off of it. And what goes out is hopefully your clean water. And then your aeration units, which is a lot like your large sewage treatment plants like the city of Erie, 55 million gallons. But the aeration units are about this, each about this big. It's about 400 gallons, so it's a big difference. So those are kind of the treatment methods. We had 439. So what we're doing is, these are expanding and building because people are not able to have, they're building on soils that aren't conducive, again, to have a full septic system. So their only other choice is really go into a small flow treatment facility or extending public sewer out, which setting public sewer out is very expensive and most likely sometimes not even available. So 427 are constructed, 45 are awaiting construction. We see them every single year. Every single year we have to go out and inspect these. So what we have is the city of Erie, Mill Creek, and the other surrounding. That's public sewer. Northeast borough and right around it, public sewer. So you won't see them around there. The only other ones you'll see are kind of void spaces. There's really good soils right here. It's very sandy. This is where you have a lot of gravel pits. Again, nice sandy soils. So when you're looking at, here's kind of like this area that they call the Venango silt loam, which is not very good soils, lots of clay, lots of high water table. So what do we have? Small flow treatment facilities. So ECDH oversight. Mississippi. So we've been doing these inspections now. We've got them onto a point that people know we're going to be inspecting them, but we also follow up on inspections that systems are not working the way they should be. So annual compliance reports are sent to DEP and the municipalities so they know who are the people that have good systems and are taking care of them, and the people that, you know, just have that old thing, I want to flush my toilet and just forget about it. We take a teamwork approach because this really is, it's not one person that can do this. The whole health department really does work on it. So what are the most and also with looking at it from the engineers. It's kind of the general standards that are working. When we see them breaking down, that's when we can plug sand filters, and the last thing that you want to do is see sewage kind of coming up onto the surface of the ground. Nobody wants that, and nobody can. I have just a little funny little story, but also I kick on one of these, and there's sewage coming up, and a dog runs over, and it knows it's time to take a drink of water. That's disgusting, but that's really what I've actually seen. So, broken pump, plugged tank, sewage underground discharging to stream ditch. We don't want to see that. So what happens when we see that? We have to now go into the next section, sometimes with alum to take phosphorus out. If they know that they've been exceeding phosphorus, they have to do alum control. Alum attaches to phosphorus, makes kind of like a flock. It looks like a snowflake. It actually falls to the ground, and then they have to remove that. So this is kind of literally what it looks like. It's all underground for the most part. That is not what we... When it comes to the surface like this, we know that something's wrong. So, what do we go? We go to the Great Lakes. We have here, Great Lake effluent sampling. So we're doing 278. Now, a lot of people don't realize it, but why is that line there? It's actually a continental divide. Everything goes to Lake Erie, that is in the blue. Everything else goes in kind of the French Creek down through the Allegheny, to the Ohio, to the Mississippi, and then out to the Mississippi, or out to the Gulf of Mexico. So we do have what is called a continental divide in Erie County. It doesn't need to be the huge mountains out there in Colorado and Utah that you're thinking about. We actually have one right here in Lake Erie. So since this is the Great Lakes Restoration Initiative, we're looking at sampling every single one of these and seeing how they're doing. How is that effluent doing? Is it attributing to the harmful algal blooms or is it not? In the first round, we did half of the Great Lakes system, but we also did Green Township, which just got picked up by public sewer here. So what happens is a lot of this was going into the Presque Bay region. Now it's on public sewer, or it's becoming on public sewer. So we're taking out those that were potentially loading Presque Bay, which is going against the harmful algal blooms. And now what we've done is it's public sewer. So that's one way that it actually can, but a full municipality had to do a very large project to pick up only 25 of these small flow treatment facilities. Here's us sampling in action. We always never have the best weather. Blue gloves, we're dealing with sewage outfall. I know, it's nice and clean. What we're doing is this one is taking a test, but as you can see inside that bottle, it actually looks pretty clean and clear. It's not always a great indicator, but it is a good indicator. So as we're doing 278 of them. We have done, at this point, and received all the results, samples from 135. We're doing our second sampling event right now, and we've received about 50 of the 120 back so far for this. So what did we find out? That's good effluent, that's bad effluent. We don't want to see that on the left. It's not a non-compliant system because someone is actually caring about it, but the system that was installed was not excellent for their lifestyle. They're not using it enough, and so the system doesn't have enough food to feed it, and usually that's what we end up getting. It's kind of like a black effluent. On the right, there's a nice clear effluent. That's what we want to see. So, what did we find? 30% of STFs would meet all parameters, so that means 70% would not. That's a failing grade. 58% of the small flow treatment facilities would not be able to meet the current phosphorus guidelines. Phosphorus is the loading for anything in the Great Lakes system, has to be 1 milligram per liter or less. We're finding right now that about 58, with all the new ones that are coming into, and I'm just analyzing that, we're finding that it's kind of staying about that same trend. So we might have to now come up with new technology to make sure that we're moving phosphorus from these systems. Now when we look at these systems, again, most of them are about, for residential, is 400 gallons or less. So 400 gallons or less, quick, simple, and easy. If you do the mathematics, the loading is much, much less than the city of Erie, which 55 million gallons on a daily basis is much different. So significantly reduce the stream loading in public sewer at Green Township. We did that by the 25 systems. And in 2008, 95 systems have been sampled so far. We haven't received all the results back. We got about 50 of the results back from our state lab. So, results to be determined on that. We're going to do all of them. We're going to do it again and sample all of them so that we can actually do a test. Is it working with us going out on a daily or on a yearly basis, making sure that these systems are working and are in compliance? So that's kind of this is our base. We're going to see what happens with next year as we're going in year after year after year of looking at them. So I hope I went quick enough to kind of bring us back on.
We have time for questions, if there are questions.
Any questions?
Did you sample E. coli when you did that?
I'm sorry?
Did you sample E. coli when you did that?
Fecal coliform is actually what we did. More of the phosphorus, nitrogen, carboniferous biological oxygen, 5-day total suspended solids, and fecal coliform.
Did you see if a system was not functioning properly? Did you see very high values for fecal coliform?
Really, it's even if they have a malfunctioning system, if they have a working UV or a working chlorine, it works. And so that's where, when we come out, we actually see it's kind of a lazy aspect to the person that's doing it. They're not checking their UV. Sometimes people have a problem, or they're not putting the chlorine in. That's a good indicator of that. Yes, ma'am?
How did you select Green Township to move those off onto the public?
That was not, Green Township has been doing studies for the last 20 years. And it finally came to a point where the constituents and the supervisors decided that public sewer was their only way. They were having so many malfunctioning systems up in that area that people were going to have to be vacated out of their house, or something had to become done. So that's where Green Township decided that they're going to have to go with public sewer. It's taking off a lot of malfunctioning septic systems. It's also taking off 25 of those other systems, but it's taking the loading off of 4 Mile Creek and 6 Mile Creek. Yes, ma'am?
I've got 2 questions. One, so if you show up to one of these places or somebody's house, I'm not quite sure how to imagine this, do they get fined if they're, you're describing them as lazy? How much financial hardship do they go up against if they didn't replace their QV?
The financial hardship for these, they cost about the same as a septic system, which can be anywhere between about $12,000 to $20,000 for a system. A septic system can be about the same. The last step that we'd ever have to do is ever find someone. We don't find them. That actually goes through the PADEP. So if we find a multiple person that just doesn't want to do anything, doesn't want to do anything, we go to the PADEP. They come up and do a joint inspection with us. And then after we do that, we kind of determine how can we take the best course of action to fix this. And a lot of times we don't even get to that step. There might be one person, there's one person really that has gone to that extent.
My next question,
then it goes to cost again.
Ah, okay. Cheaper
And-
for you guys to go out there than it is to buy a pro?
I'm sorry?
It's cheaper for you guys to go out there than to like buy a pro system?
Yes, that's what I paid them, yes.
Yeah?
Yeah.
Okay.
Thank you very much.
Great, thank you so much. All right, our next speaker will be Kayla Kroczynski from Indiana University of Pennsylvania. And she'll be speaking about something. She'll be speaking about stormwater runoff from a recreation complex in Indiana, Pennsylvania. Yeah, and then I have signs here. I'll give you warning.
Okay, good afternoon, everybody. My name is Kayla Kroczynski. I'm a senior geology major at Indiana University of Pennsylvania, or IUP, and today I'm going to be talking about my research on stormwater runoff at the White Township Recreation Complex. Okay, so stormwater runoff is runoff created from a storm event and occurs when rain falls on impervious surfaces, cannot soak in, and then runs across the surface as runoff. Impervious surfaces are defined as surfaces that water cannot infiltrate into. The most common impervious surface is pavement, but this also includes surfaces like tennis, basketball courts, and roofs of buildings. This image here shows that as the amount of impervious surfaces increases in an area, the amount of infiltration decreases, which therefore increases the amount of runoff. So here we start off with the natural ground cover, and only 10% of the rainfall turns into runoff. And as you increase and get up to 10 to 20% impervious surfaces, the runoff increases to 20%. Get up 35 up to 50% impervious surfaces, you're getting 30% runoff. And then in cities where you have 75 to 100% impervious surface cover, you get up to 55% runoff. Okay. The picture on the left shows Indiana County highlighted in red, which is the county where I'm working in. And the picture on the right is a Google Maps image of the town of Indiana with the red markers showing the location of the complex. The runoff from the complex drains into a stream called Marsh Run, which affects a large area as seen in the Marsh Run watershed map on the left. Marsh Run is a headwater stream, which means that all of this runoff affects all of the water downstream in the watershed. The entire complex is 50 acres, which accounts for 3% of the total 2.5 square mile area of the watershed. And the picture on the right outlines the complex in red. Okay, this image again outlines the complex and shows the included baseball fields, tennis courts, basketball court is here, the S&T Arena building, and the roof and parking lot is here. This is a wooded property. This is the upper hill and park area, and these are the soccer fields. And the S&T Arena roof is 1.6 acres, which amounts to about 1.2 football fields. Okay, as I mentioned before, impervious surfaces include surfaces besides pavement, and the complex has multiple of these surfaces. So starting from the left, the first picture is of the tennis courts. The second picture is the driveway down to the lower parking lot. The third is the arena, which goes back farther than the picture, but that's the building in blue. And then the arena upper parking lot. And then the last picture is the driveway that leads out of the complex. Okay, so this image shows how slope is calculated in ArcGIS. It shows flow direction, which is showing where water flows within the complex. Then the flow direction is used to create flow accumulation, which allowed me to divide the property into smaller drainage sections. So here the flow accumulation is shown in the lighter colored lines, which was used to split the complex into the 6 drainage polygons outlined in red. And this is on top of the DEM I use, which is a digital elevation model, which is the gray. So here are the 6 drainage polygons again over top of the ArcGIS image of the property. The 6 polygons were grouped together into 4 polygons based on where the water exits the complex and into marsh run, which is shown here on the blue as the blue line. So this blue polygon, which includes the baseball fields and the arena parking lot, exits throughout this through a pipe in this corner out up here. The wooded property exits through a pipe underneath the baseball fields and out here. The upper hill and park exits through a pipe again underneath and comes out down here near the end of the driveway. And the soccer fields drains down through the driveway and comes out here. Okay, so I imported soil data from the NRCS, which is the Natural Resources Conservation Service, which is part of the USDA. And this image shows the polygons in red with the different soil classifications in the pastel colors. This information is helpful because it allows me to determine how water will infiltrate into and flow over the different soil classifications. And the main differences between the different soil classification types includes the soil type, such as silt loam, silty clay, loam, and bedrock, and the slope of the land. And both of these affect how much water can infiltrate into the soil, which therefore affects how much runoff there is. Okay, this image shows how I intersected different polygons on ArcGIS. So if you start off with 4 polygons here that I described as 4 flow zones, and then I wanted to intersect it with these 3 soil zones, I could do that and end up with 12 intersected soil drainage zones. So for my specific model, I had 6 polygons that I intersected with 14 soil zones, which ended up giving me 31 soil drainage zones. So these are my model conditions for my ArcGIS. And I began by modeling a 1/2-inch rainfall per hour over the entire complex. I used the soil infiltration rates to determine the volume of water that may be generated as runoff. And then I used these numbers of runoff to investigate the impact on marsh run. Okay, so the steps that I'm working on currently involve modeling the 1/2-inch and then a 1-inch rainfall per hour over the entire complex. I use the soil infiltration rates to calculate a range of water generated as runoff, and then I'll be using these numbers to investigate the impact on marsh run. To give an example, I'm going to go through the calculation for this polygon here in dark blue. Okay, so modeling a 1/2-inch rainfall per hour, ArcGIS calculated this area as 118,000 square feet. And the soil classification is ERB, which is earnest silt loam, and it's on a 3 to 8% slope. And that soil classification generated the minimum and maximum infiltration rates of 0.06 inches per hour to 0.6 inches per hour. Okay, so using the infiltration rates from the last slide, I get these 2 numbers here as the possible runoff amounts. The minimum runoff is 0 because the soil in this polygon would actually be able to absorb all of the water generated from 1/2 inch of rainfall per hour if the water infiltrated at the maximum rate of 0.6 inches per hour. The total runoff for the entire complex is this range here, between 29,000 and 101,000 square feet. And the 4 exit polygons are divided into their runoff ranges here. And 1 cubic foot is about the size of a basketball, so that helps you kind of like try and visualize the amount of water that's going into the stream, and this is just over a 1 hour period. Okay, so for my future work, I'll be installing a data logger, which will measure the volume of water coming through that area, and this will allow me to compare the data I get from this logger to the numbers I get in the ArcGIS model. I will also be conducting infiltration studies, which will again allow me to compare data between the rates that I got from the Minnesota Storm Manual and then the actual infiltration rates that I get from the study. Then I'm going to be doing research on different green infrastructure options that the White Township officials could implement at this complex in order to help reduce the runoff from this complex. And eventually I will be presenting my findings to the White Township officials. I'd like to thank my department, especially my research advisor, Dr. Farnsworth, and also the people at White Township, especially Matt Genscher, for helping me get this project moving, and the Indiana University of Pennsylvania Research Experiences for Summer Scholars for giving me funding for this project.
Does your study account for seasonal variations, or is this mainly just for summertime, like thunderstorms?
It doesn't really account for seasonal variations. I would say it's mostly just for one season.
One of the things we struggle with the Weather Service is the seasonal impacts of, the growing season on the runoff, and of course, once the ground's frozen, how that.
Yeah, that's true. That would be another point that would be important to look at. Yes.
When you set up your model, did you make any assumptions about what the actual moisture of the soil was before you modeled the rainfall condition? So did you assume that the soil was all even? Did you assume that it was dry or wet? Or is that just represented by the range of infiltration?
Yeah, I think the range helps show because of between like the minimum and maximum infiltration rate. So that just includes all that. Yeah.
First, excellent presentation. Thank you.
Thank you.
And did you subtract the amount of impervious surface from your soil maps on your GIS layer, or did you assume that it was all permeable soil?
I did subtract.
Yeah. Those at zero. Wherever the pavement was zero.
Okay. Okay, I understand.
So yeah, it was subtracted.
Any other questions? Great, thank you. All right. Great. All right, so we'll move on to our next speaker, which is Joseph Duris from the U.S. Geological Survey, who will be talking about a very long thing, but about pharmaceuticals, it's much shorter up there, pharmaceuticals and personal care products in raw and finished drinking water.
I did that.
Thanks.
I did that because it seemed too long. So my name is Joe Duris. I'm the water quality specialist at the USGS Pennsylvania Water Science Center down in New Cumberland, which is Harrisburg. I'm going to present some information today from a study that we conducted in 2016 related to the occurrence of pharmaceuticals and personal care products in raw and finished drinking water. The primary folks who worked on this were, and I don't want to do the wrong label. All right, good, I got the laser. Were Robin Brightville and Drew Reif from our science center. They asked me to present, and so I'm here to present this for them. So I'm just going to start by giving just a little bit of background. So in 2012, we published a study that was a kind of a multi-year evaluation of pharmaceuticals and personal care products. And you'll see me abbreviate that as PCPPs because that's easier than saying pharmaceuticals and personal care products again and again. And what this study showed was that there was kind of a really diverse assortment of pharmaceuticals and personal care products throughout the state. We found them in groundwater, we found them in surface water, we found them in relation to wastewater treatment plants, and we found some in specific relation to different types of land use. And one of the parts of this study was actually looking at water that served as source water for drinking water, for communities, for public supplies. However, we, at that time, didn't do an extensive evaluation of that finished drinking water. We were looking more at the source water in the environment. So this kind of led to the idea that maybe we should kind of follow up on this, see if we're seeing some of the same compounds that we saw in the late 2000s before this was published, and also then to evaluate if those compounds were the same, and then if it was any of those compounds were also occurring in finished drinking water that was paired with source water. So just to kind of give you a concept study, this actually fits really nicely with the other talks that we just had about stormwater runoff and E. coli at beaches. This is all the other stuff in the water that we don't necessarily think about as being common environmental contaminants. So we heard about phosphorus, we heard about E. coli and fecal coliforms. Those things are all associated with wastewater as well. These compounds, these pharmaceuticals and personal care products, are the things that we take that maybe our doctor prescribed to us. Or maybe we've got an ache and a pain and we go and we take some Advil or some Tylenol, right? Well, our livers and our bodies and our kidneys are very effective filters. And so what we do is our bodies filter those things out of us, and then we eliminate them in our urine or in our feces. We flush that toilet, just like we heard about the different types of low flow systems, and that goes to a treatment facility of some type. Most treatment plants are not designed to take out very small levels of organic compounds, such as these personal care products that we're evaluating. So you have a wastewater treatment plant that collects the feces and urine from a community. It treats it, it removes phosphorus and it removes E. coli, but then that water gets discharged usually into some sort of receiving stream. And then somewhere downstream, there might be another community that actually uses that same water and pulls it in, and then they do another treatment process on it to treat it and turn it into drinking water that then is distributed into a public system. So our idea is to say, okay, well, if we have this setup, can we sample water here and then sample water here, and do we see any of the same compounds? So we're evaluating these things like prescription drugs, over-the-counter pharmaceuticals, different personal care products that people use in their homes. So the objectives were, as I've kind of stated, to look at current concentrations of PPCPs in raw water samples at 6 stream sites that were previously sampled near drinking water intakes in the Susquehanna and Delaware River. That was that study that I mentioned. And at a water treatment plant where raw water is intaken from Lake Erie, so we actually have some local relevance here. And then determine current concentrations of PPCPs in drinking waters produced from 5 of the stream sites and Lake Erie. So those are kind of just our succinctly stated objectives to give you an idea of the geographic distribution and where we sampled. We have Lake Erie up at the top, we have the Susquehanna River at Danville, the Juniata River at Newport, the Connewagowinet Creek near Hoagstown, Yellow Breeches Creek at New Cumberland, that's right near our office, that one's very convenient. The Delaware River at Trenton, that's the big river, and then Schuylkill River at Fallsbridge, Philadelphia, so Schuylkill River at Philly. And as you might imagine, the Delaware River at Trenton and Schuylkill River serve very large populations. There's a lot of wastewater treatment that's happening, and there's also a high demand for the water. So water from the Schuylkill and from the Delaware is used extensively as drinking water. So that's kind of the regional distribution of these sites. I also like to say this because when I first arrived here in Pennsylvania 2 years ago from Michigan, when I saw names of rivers like Connewagowinet, I almost didn't know what to do. So I feel like I'm really like getting a hang of this Pennsylvania water naming conventions here. So let me tell you a little bit about how we collect our samples. So for stream samples, what we do is we use a common process for the USGS called depth integrating equal width method. What this basically means is that rather than just going out and dipping a bottle in one portion of the stream, we actually put that bottle on the end of a rod and we move it up and down through the water column. And we do that in one section of the stream, and then we move to the next section of the stream and we do it there. And we do that typically in 10 sections across the stream, and then composite that in a vessel so that we have an accurate representation of the entire section of the river at that point. And that's important because a lot of drinking water intake plants don't just use a single pipe as an intake. They use multiple pipes along a channel in order to bring water into the plant. At that point, then, we dump from our Teflon bottle into a Teflon churn. The Teflon is important because all those little trace organic molecules that we eat and excrete, they stick to plastic pretty extensively. So we use Teflon because the pharmaceuticals don't stick to it. They're mixed together in a Teflon churn, and then a small aliquot is pulled out and filtered through a 0.7 micron filter into a 20 milliliter amber glass vial. So we collect about 10 liters of water, and we end up analyzing about 20 milliliters of that. The samples are then chilled, and they're sent overnight to our USGS National Water Quality Lab in Denver, Colorado. Once we've collected the stream sample, then we go into the drinking water treatment plant, and we collect typically from a spigot or pipe that contains the finished water before it's pushed out into the distribution system. So we're not going into somebody's home and sampling out of a tap. Instead, we're sampling out of a spigot in the actual drinking plant itself. That's processed in essentially the same way. A couple differences, though. We do put ascorbic acid into the initial sample bottle. That helps to get rid of this excess chlorine that's in the water. Usually right at the end of that drinking water treatment process, there's a lot of chlorine in the water still. So we take that chlorine out with a little ascorbic acid prior to our filtration, then we fill the bottle and we send it to the lab in the exact same fashion. So once it's at the lab, the lab uses a liquid chromatography tandem mass spectrometry for you chemistry folks out there. That's LC-MS-MS. We test for 128 different compounds that include acetaminophen, which is Tylenol, albuterol, which if anybody has asthma, you probably know what albuterol is. It's an inhalant that helps to vasodilate. Amphetamines, so this could be prescription amphetamines or non-prescription amphetamines that would be illicitly used drugs. Caffeine is very common. Codeine, again, pain management, and then also everybody hears about fentanyl and all those things. They do turn up on some of these different analytical schedules. Diazepam, which is Valium, nicotine, prednisone, which is an anti-inflammatory, warfarin, which is a blood thinner. That's really commonly prescribed, and we find it in a lot of water. Various different antibiotics, a bunch of different painkillers, antidepressants, anti-anxiety medications. The list kind of goes on and on. But what the kind of common thread of these is that they can be extracted by a similar chemical process at the lab. And they're also in, I think, the top 500 prescribed drugs in the United States, so, or commercially available drugs in the United States. So, what do we typically find? So when we looked at this previously, the number one thing that we find in water that kind of fits into this category is caffeine. We've probably all had a cup of coffee or a can of Diet Coke today, or maybe some tea this morning or something like that. Very common. We all ingest it as a stimulant, and it passes right through our bodies, and our kidneys effectively filter it, and then we excrete it, and then it ends up out in the environment. Very commonly detected all across the country, not just in Pennsylvania. Another very common contaminant that we detect is called carbamazepine. Carbamazepine is not a very highly prescribed drug, but it is very recalcitrant in the environment. And what that means is that the molecule itself is very resistant to breaking down once it gets out into the environment. And so we typically find that in relatively high levels because once it gets there, it doesn't usually go away very quickly. Acetaminophen. So we see Tylenol a lot. We also see ibuprofen quite frequently. So we see these kind of over-the-counter pain medications. In our previous study, we found diphenylhydramine, which is Benadryl, very frequently. And we found cotinine, which is actually a metabolite that your liver makes when you smoke, or ingest nicotine. So it's what you excrete when you're a nicotine user. So these were kind of some of the things that we expected to see when we collected samples for this round of the study. And indeed, we did see a couple of kind of common things. In our most frequently detected compounds, we did have carbamazepine. That was not an unexpected thing. We didn't put caffeine on the list, but caffeine was, again, our #1 detection. That's the most frequent thing that we detect. But we did see that some of the things that we're detecting began to change a little bit. In particular, there was a couple things I wanted to highlight. Rather than Benadryl, now we're seeing fexofenadine, which you might not know, but that's Allegra. So, you know, we have these allergy medications, Benadryl and Allegra. We didn't see as much of the antihistamine Benadryl, but we did see this fexofenadine Allegra in a lot of our samples. We saw lidocaine this time at a number of our locations in both drinking water and in source water. Let's see, there's a couple up here that you may know. Bupropion is Wellbutrin or Zyban, so that's given to people to quit smoking, and as an antidepressant. Desvenlafaxine, I practiced it too and I still can't say it. Desvenlafaxine is Presque, it's an antidepressant. Methocarbamol is a commonly prescribed muscle relaxant. And then we have this kind of interesting methyl 1H benzotriazole. That's used as an antifungal, but it's interesting because it's also actually used commonly in the manufacture of other drugs. So it serves as a precursor molecule for a lot of other drugs. So we're finding that in relatively high levels. And these two numbers that you're seeing here are the average concentrations that we observed in surface water and then in the subsequent drinking water sample that we collected. So, you know, you can see that these are all fairly low. The unit here is nanograms per liter, which is parts per billion. So that tends to be pretty small. However, when you see things like metformin, which is given for type 2 diabetes treatment, you see that in our surface water sample, we're actually getting to 0.7 of a part per million, which is that's getting up there. So kind of some interesting results. And this is the point where when we get these samples back, we always look, and then now the question that you're all asking yourself is, okay, so what does that mean? And I think that's a good question. So just to show you some more ways to look at the data, we have the compound across the x-axis here, and then we have the number of sites with detections. So you see, and this is a repeated sampling, which is why the N is 14. So you see, again, these are the ones that I just kind of covered. I think the big takeaway here is that while we are frequently seeing these in many surface water samples, we see them much less frequently in the drinking water. So even though the treatment in drinking water is not necessarily intended to treat for these compounds, we do see them less frequently and in fewer variety. So in most cases, we go from a relatively high number of compounds detected in the surface water to a fewer compounds detected in the drinking water. So I think that's really good. You'll notice Schuylkill is suspiciously absent. We had a drinking water supplier who decided at the last moment that they did not want to participate in the study, so we did not have that information to present. So what does this all mean? Well, pharmaceuticals and personal care products, they can be harmful if they're in our drinking water. The World Health Organization has established acceptable daily intake values for a variety of these personal care products. And as you might imagine, these compounds are designed to be active inside of people, right? They're designed to do something biological in our bodies when we ingest them. So when we compare these, our values to these World Health Organization values, our values are much smaller, right? The values that are unsafe tend to be 10 or 100 times higher than the concentrations that we observed in the water. So, basically what that means is that we're kind of chronically being exposed to things at very low concentrations with an unknown effect, really, for us in our drinking water. It's much lower than is recommended. So the standards or the values that do exist to kind of compare these two are much higher, as I said. But we are observing these compounds in our drinking water. So what this means is that we have a process that basically shows us that we're recycling our water around and around, and we are ingesting some of these compounds. And I also want to point out that keep in mind, like I said at the beginning when I was talking about the analysis, that these are the compounds that we can get easily analytically and that are prescribed. This doesn't account for potentially all of the other things that could be in the water that we're not testing for. And there is some push in in some of our environmental chemistry labs to start to do what they call unknowns analysis. So rather than focusing on 128 things you know, try and look at the whole graph that you get out of the instrument and start to try and identify what those peaks are. So that we can let the data tell us what to look for instead of us looking for the things that we think are the right things. But again, they can be harmful at these low levels. There's not a lot of information that says if they are. And that's for people. Now, I've kind of said that there's not a lot of treatment available, or not a lot of drinking water treatment plants that do treat for this. However, there is treatment available. You may be familiar in Montgomery County. Recently, there was a GAC system, which is granulated activated carbon, put in place to treat for perfluorinated compounds that were found in the public supply there. So granulated carbon, activated carbon is effective at absorbing these, but that's very expensive to do. You have to run all your water through carbon, and then you're left with carbon that has a bunch of chemicals stuck to it, and you have to take it out and do something with that. There's also advanced oxidation, so you can use ozone. That effectively eliminates a lot of these chemicals as well. But again, these systems are very expensive, and they're not in high use currently. However, the more that we see these kinds of compounds, the bigger the number of people that are supplied, the more that systems are moving into these advanced treatment methodologies. I think this is an interesting fact. So we did a little calculation back in the envelope, and it turns out that you would need to drink 4.7 million gallons of the highest concentration in order to get an effective dose of what you put in your mouth. So a day. So I hope you're thirsty. But I think that's kind of interesting. Now, the other side of that coin, though, is that these compounds are in the source water. They're typically higher concentration. There's more diversity of these pharmaceuticals and personal care products in the streams. And what that means, because the fish don't just drink the water, they live in the water, right? So they have a chronic exposure where we have a much smaller exposure in our drinking water. And the USGS and the EPA and the Fish and Wildlife Service have reported extensively on this. There are many reported effects from having personal care products in our drinking or in our source water. These include feminization of fish populations, meaning you have male fish that develop secondary sex characteristics of females. You get reduced reproductive effects, meaning fish have smaller broods or their broods don't survive as well. Fish get tumors very easily. And then there's increased parasitic load and diseases in fish that are exposed to these compounds. There's even a study that looked at venlafaxine, which is a common antidepressant, and they exposed smallmouth bass to it, and what they saw is that the male smallmouth bass, when they were exposed to environmental concentrations of venlafaxine, would migrate off of their beds, and they wouldn't defend their beds with the same tenacity that they did when they weren't exposed. So really interesting things that are happening in the environment, but they're very subtle things that are happening as a result of these compounds. So conclusions, PPCPs were detected frequently in source water, less frequently in finished drinking water. I think that's a good thing. They were detected at higher concentrations in source water when compared with drinking water. Again, unintended effect of the drinking water treatment process is it is reducing the number of these, the frequency with which we see them, and the concentrations. And when we do see them, the concentrations are much lower than what a therapeutic dose or even an effective dose would be. As a final kind of thought, that the PPCPs, these pharmaceuticals and personal care products, in source water, meaning in streams, can definitely cause aquatic life effects. So we'd like to acknowledge the Pennsylvania Seed Grant for funding for the study, Heather Eggleston-Bender, Lee Eichholz, and Leif Olson for collecting samples. And I'd be happy to take any questions.
On your chart, Lake Erie.
Yep.
Shows 39 being how much had source water, but it was 39 for our drinking water.
Right. So
why are we not, in our water, not showing it go down?
So we didn't investigate the why, unfortunately. But what I would say is that you know, I'd have to go back and look specifically at that data. But you know, different treatment plants are set up different ways. And so, as I kind of pointed out in the Delaware and Schuylkill, where they know that they're serving, you know, millions of people, they have some of the more advanced treatments there. And Erie may not have that same level of advanced treatment. But again, the goal of the study wasn't to evaluate the why, it was more just the is it occurring and does it make it through the treatment plant. So I think in follow-up studies, it would be important to collect the specific information about each drinking water system, and then we can start to look at, are there compounds that are coming through different systems as a response to the kinds of treatment that's put in place. And I think just based on kind of the engineering pieces of this that I've read, that there would be a pretty significant difference. So that's yeah.
Joe, you had a graph that showed numbers of compounds detected in different water bodies.
Yep.
Did you look at differences in concentrations and or more particularly mass loading among different water bodies?
So we didn't look specifically at mass loading because, and that's a good question. And I think that the reason that we didn't is really because there are so many sources that we didn't sample. So it might be a little kind of spurious to get a load from one individual, kind of area of the watershed and then extrapolate that to the whole watershed. And you know, if you look at NPDES permits up and down the watershed, you're going to have, you know, in some cases maybe even hundreds of wastewater treatment plants, right? So it's to do one area and say that it represents the whole watershed. Now I will say that in our in that earlier study, there was enough data and it was spread around a little bit more geographically. But I don't think that was actually something that we looked at to look at the load. But I think that the mass is certainly important, and it's something that we should probably focus on a little bit more. Yeah, just like with phosphorus, right? When we think about, oh yeah, well, what's the concentration? Well, you know, the cyanobacteria in the lake care more about what the mass is than we do about the concentration. So.
Great. All right, we have to move on. Sorry, we're out of time.
No, that's right. Yep. I'm happy to talk.
Joe will be around to answer questions. All right. Our next speaker is Sarah Jameson from the NOAA National Weather Service, talking about harmful algal blooms and NOAA's focus.
Thank you, Katie. And thank you, Joe. I'm going to stick to bottled water from now on. Okay, I'm going to start off by stating outright, I am not a subject matter expert on harmful algal blooms. I am part of Team NOAA, though. The representatives in our agency who focus on the algae blooms are based out of Washington, D.C. and Ann Arbor, Michigan. And since neither of them are present today, I will be speaking on their behalf. So if you have questions, shoot it to them. Okay, as Katie mentioned, I work with the National Weather Service office in Cleveland, so you can't blame me for the forecast. Another subject. All right, when we talk about HABs from the NOAA perspective, this is, you know, going 50,000 feet. We're talking about a national problem. This is certainly not an isolated issue for Lake Erie. You know, we've all heard about the issues down in Florida, but they're really an entire national crisis. And if you're directly impacted by HABs, it's the biggest crisis of your day. You know, it's very important to those being directly impacted. So obviously we are not in isolation. When it comes to addressing harmful algal blooms, NOAA shares the responsibility with the EPA on a federal level. This was started in 1998, reaffirmed in 2004 and 2014 with the Harmful Algal Bloom and Hypoxia Research and Control Act. Basically, NOAA is responsible for the fresh water, and the EPA is responsible for the salt water, though there's overlap by both agencies. Okay, so NOAA's key role, detection, monitoring, assessment, forecasting, research, and education and outreach. I'm sure shared by the EPA and probably USGS and other agencies, but this is our specific charge when it comes to algae blooms. For Lake Erie, you can't talk about algae without emphasizing the cyanobacteria, the microcystin, which is the form of the toxin. And when we talk about harmful algal blooms, unfortunately, we're not talking about the toxicity, because the products that NOAA is putting out does not specifically address the toxicity as much as it is the aerial extent of the hazard. And we all know that there's quite a difference day to day with the toxicity of an algal bloom. So I had to make that clear. So being with the National Weather Service, I can't say I knew too much about algae blooms at all, other than that they existed, until this happened. And then suddenly all of NOAA really set up, especially locally, and realized, okay, we need to be better at our education, our outreach, and then also let people know what we're doing to try to address these problems. So obviously the Toledo water crisis really got a lot of national attention, and unfortunately it takes crises for the attention to be drawn to certain areas. Okay, so for detecting and monitoring, NOAA does not specifically provide the equipment for monitoring and detecting. What we do is we work with local, state, and other federal partners to collect the data and then do the analysis on it. But we do not specifically have our own network of gauges and stuff that we have out there that we use. Again, we work with our partners. GLERAL, is anyone familiar with GLERAL, the Great Lakes Environmental Research Lab, Ann Arbor, Michigan? Wonderful, wonderful information on algae blooms from their webpage. I'm sorry, are you from there?
that site.
Oh, okay. I was going to say, you can speak for me if you're from there, because they're the experts on this, but they have a wonderful webpage that's linked here. They've got everything from educational information, experimental tools that they're developing. But specifically for the detecting, what they have, I want to make sure I don't turn this thing black. Is it the middle one? How do you do the laser? Middle? There, okay. This is more for Western Lake Erie. I'm afraid Western Lake Erie hogs all the attention for the algae blooms on Lake Erie, and that's all that NOAA addresses. I've spoken to our people in DC about the problems in Presque, and given the grand national problem, let's just say it's kind of far down the list, but they're trying to tackle things from such a large perspective that, it's hopefully in the next 5-10 years with the roadmap of NOAA we'll start to address these more localized problems, but it's not on their radar right now. What they do with their monitoring stations in the Western Basin is that's where they can actually collect the information on the toxicity of the bloom. That's not what they're forecasting, but at least it gives them that information. Plus, we collect the scum observations. Anyone ever seen the bloom out in Western Lake Erie or the one off here in Presque? You can kind of walk to Canada. It's pretty impressive when it develops. Okay, here's an example. That's the water intake for the Toledo area, and that's a monitoring station. They also have these fantastic buoys that take real-time data. Now, anyone who's in the research or the modeling field, you know how valuable real-time is. So this information is collected every 15 minutes and relayed. There's 4 buoys that collect the information. And that's basically through the HAB season and the warm season, June through October. All right, so we collect all this information, forecasting, and this is where things are really starting to move with our ability to forecast. So once we get to the early season, we start to look at the loading season of the phosphorus and the nitrogen into the lake during the spring season, mainly that May through June period. And by the time we get to mid-June, we have a pretty good idea on how much loading there's been from the spring. And what happens is at that time, usually around the first week of July, NOAA will put out a forecast on how bad or how severe the bloom is going to be. So this was from this year. Actually, no, I'm sorry, this is 2017. So these were the past severity indexes of the blooms versus what they think is going to happen. And in typical NOAA forecasting, we give you a very broad range of what we think it's going to be. And there's a reason for that. But this is an experimental project. There's still, it's out there. It's for public dissemination, but basically they're still kind of testing it. So here's an example from that year, 2017. Everything was kind of going on looking like normal. These are past loading seasons. As you go through, starting in March, you know, you look at the rain and the runoff and basically the Maumee River Basin, which is in western Lake Erie by Toledo. That's like 90% or plus of the loading for the Lake Erie HAB. There was a really heavy rain event in May, and you just saw the loading shoot up. And by the time when they saw that, they're like, oh, okay, this is going to make it a worse HAB this year than it might have been the year before or the year before that. So that was a real signature of a bad year. And so by the time they did the forecast, this is what they put out there for the likely and then maybe even possible severity of the HAB. Once we get into the season, they actually do a HAB forecast. It's issued from July through October. They issue it 2 times a week, Monday and Thursdays. Does anyone in the room happen to get? Okay, a few of you do. You've seen this. It's a very technical product. You know, one of the things that as an agency we're discussing is how can we better disseminate this for your general public users, your boaters, your people who have cabins in the lake and so forth, because it's very technical, as you've seen. Even people who are familiar with the terminology, it's kind of overpowering some of the technical terms that they put in it. Basically, people want to, excuse me, most of the people I talk to, they just want to know where is it? Is it bad? The visual's enough to tell the story. But this is how they develop it. Basically, we're relying on satellite imagery that they then process, and don't ask me the process, but then they process it, and then they can identify where they're detecting the HAB or the cyanobacteria. And then they give it a density index. Okay, a few little caveats. If there's clouds, guess what? We can't see it. But there's never clouds on Lake Erie, so we don't have to worry about that. So there's only about 20 to 30 usable cloud-free days or times that they're doing the shots that, you know, we can clearly see what the bloom is doing. So that's a big limitation. Luckily, it doesn't change too dramatically. But if we get a really good mixing day, a lot of wind, then boy, that can really affect your surface scope. And then sometimes it's hard to distinguish between muddy water from like a high flow event coming out of the river and what's algae and what's mud. Another huge distinction. But once they've identified where the algae bloom is, they will use the forecasted winds over the next few days to try to tell you where it's going to move over the next few days. So that's the forecast component of their product. So I love this. This is just a little snapshot of HAB over the last few years. You can see based around the same time of year over the last few years how the variances have been. And I loved last year. You guys remember we had that nice warm up in October? That algae was starting to get reduced. We were starting to cool down in like typical September fashion. Not like this year. And then bam, it warmed up and the bloom just like blew up again. It was like, oh, come on. This year we had that heat wave. I mean, we had 2 Augusts and then we dove right into winter. We didn't see that because we didn't have as much of a bloom initially anyways. It was a fairly mild bloom this year. Another thing that's experimental that Glarol puts out, it's actually a 3D model, which is very interesting because as you know, the wind will stir it up and the HAB might go under the surface, but that doesn't mean it's gone. It's just kind of hiding there for a little bit until it settles right back up to the surface. So a lot of water intake communities like Cleveland and Toledo, they want to know where it is on a 3-dimensional scale. So they're running these 3D models as well, which are pretty interesting. Okay, here's the seasonal assessment for 2018. The forecast that came out in July is this box whisker up here, and this is what actually happened. So, like I'm a forecaster, it happens. What happened was we started off, we were fairly wet in the spring, especially up here, but then once we got into summer, it really dried out. So their anticipated loading for the months of June and July just didn't materialize. It happens. No one's complaining that we didn't have as bad a bloom this year. So, the Weather Service, again, we're part of basically a megaphone for what NOAA's putting out there. We try to be kind of a one-stop shop if you're a boater and you want to go out fishing. You know, it's like, well, come to the website. You can get your marine forecast. You can get information on where the bloom is. Some of the stuff that was discussed here, we could even incorporate, but basically we have what's going on with HAB monitoring, public water systems, recreational boat, waters. Basically anything that has to do with HAB, we kind of want to have it linked on here for Lake Erie. So contact me if you want anything to be added or want to have a discussion about that. Okay, research. I'm not a researcher. But NOAA's research goals are in detection and forecasting. As I said, we're not identifying the toxicity, and that's something that we're really, really trying to strive for, is we want to be able to tell people, yeah, it's scummy, but it's really not that toxic, or you better stay out remotely. And that's the challenge that we have right now. And then forecasts, there's always room for improvement when it comes to forecasting. We want location and toxicity. One of the things that they're working on is using airplanes with these sensors underneath, so on those cloudy days, they can actually fly underneath and sample the scum and, you know what I mean, remotely, and use that information to kind of help fill in those gaps. So they've been doing that for the last few years. NASA's in coordination with that. I don't know what any expected timetable is on when they might actually utilize that in any of the forecasts. There's also some interesting equipment, some new tools. Goodness, this flow cytobot. Again, I'm not the subject matter expert on this, but basically this one, I believe, it's an underwater microscope that can be used to detect, whatever it is that you want to detect. And then we have this environmental sample processor that's, again, one of these remote sensors, so it can send the information real time, which is fantastic. They call that a lab in a can. Woods Hole is using both of these. I don't believe there's any on Lake Erie, at least none that I've been informed of. But this is kind of, I think, the future of what they're trying to get at, is this real-time sampling information. All right, so future work, we're just going to continue to work on providing more HAB forecasts and information from more areas across the country. There's more demand than we can handle right now, but it's growing. It's growing. And then we're continually trying to work with our partners to develop better research and better tools to detect it. So this is not a problem that's going to be going away anytime soon. Anytime soon. Here's a whole bunch of links that may be helpful on the HAB. And I couldn't come up to Erie and not talk about this. Elephant in the room. Yes, if you guys hadn't seen your calendars, it is that time of year, but yeah, I did the forecast yesterday, and it's like, ooh, yeah, the lake machine's gonna get going. We're probably gonna see a little bit of snow Friday morning, but that's not the show. Saturday morning, especially the further inland you are from the lake shore, yeah, if you've got gas in your snow blower, you might want to pull out your yard stakes. It's that time of year. It will likely accumulate. I don't have numbers for you yet, but hey, it's the first snow. People love the first snow, right? It's the 75th snow that you're like, enough already. And then early next week looks promising too, and that's not so much a lake effect event as just a snowstorm. So we're all going to get it. You guys aren't going to be isolated this time. Yep, so here's the temperature outlooks. The next 6 to 10 days, blue means cold. 8 to 14 days, still cold. So yeah, today's about as warm as it's going to get for the foreseeable future. So yeah, sorry. Anyone here last Christmas by any chance? Yeah, I'm not going to touch that one with a 10-foot pole, but if you want to talk about that event with Weather Service employees, we are coming back up here tomorrow. We're doing a winter weather skywarn training. That's a program where we try to educate and get people involved in the communities to report to the Weather Service. For example, the winter event last year, it would have been fantastic to get phone calls or reports from people saying, this is what I'm seeing, I was working the desk that night. We were watching the webcam at the airport. And that doesn't tell the whole story, okay? So what they're trying to do is try to get more community involvement to help us with not just snow, but we just had the anniversary of the tornado and the flash flood event from last year, so it's kind of all encompassing. But that will be going on tomorrow at the library here in Erie at 6:30 in the evening. So if you don't have any plans, please stop by. All right, any questions? We'll part on good news. Yeah.
I was just going to say, they were saying we can't say lake effect anymore.
Oh,
Got that out of the vocab now.
what they're doing, that, nah.
Took away our snow, took away our term.
They're gonna talk about that tomorrow. What they did on the national level, okay, like if I said flood, there's like 10 different flood products that we issue, right? Same thing with winter, and they're like, you know what, let's keep it simple. Let's call snow winter weather. Let's call floods just floods. And so they're trying to simplify by just kind of lumping it all together. In our warnings, we will say lake effect snow, but it won't be a lake effect snow warning, it'll be a winter storm warning. It's a nuance. Well, part of the problem here is it's not usually just pure lake effect. It starts off as a snow event that transitions into lake effect. You guys are complicated.
Is there anything or any type of monitoring related to whether or not people can eat fish in certain areas? So you're talking about odors a lot, and then you're talking about you should try to monitor toxicity. But I mean, there's a certain delay involved in them, like actually uptaking the toxin. So is there any kind of warning that goes out, like don't fish and eat the fish in this area?
Nothing I've seen with the fish. I've seen that for NOAA products for Florida.
Okay.
And then like Gulf of Maine and stuff like that, but not for Lake Erie. And I don't want to make any judgments on what that means. Whether that means they're not toxic, I don't know. I've never heard that. We will state like dogs and stuff shouldn't go in the water, or reach the point where people should go in the water, but I've never heard anything about the fish.
Okay.
I'll leave that to a subject matter expert. All right,
Great. And we saved the best for last.
Well.
Our bonus talk. All right, we have, get this here. Matt Waldron from PADEP will be giving us a presentation looking at resource mapping of shipwrecks, it looks like. Thanks. Right up there on the top.
All right, again, my name is Matt Waldron. I'm with the Pennsylvania Department of Environmental Protection Coastal Resources Program. And we've been working for a number of years on mapping shipwrecks and documenting shipwrecks within Pennsylvania waters and Lake Erie. So what I'm going to talk to you today is what we did during our 2017 field season. We actually didn't get out of the lake this year to do any shipwreck work, so this is from the previous summer. We set out with the objectives to collect new imagery. One of the things that you'll see over the next few slides is that we've really, since we started doing this work in 2013, we've really improved our image collection and processing techniques to get really good images of the wreck sites. We've really improved our detail and consistency of the images, and you'll see that. Along with that, with the better imagery that we were able to get, we wanted to see if we could do broader contextual surveys around the wreck sites to see if we could pick up any debris or artifacts displaced from the wreck sites that wouldn't have been picked up during any sort of diver surveys or other types of physical underwater surveys of the wreck sites. Something that could steer future efforts in taking a look at these locations. And then out of that, do some GIS mapping to put that into a spatial context. Let's put it on a map that we can see and develop some target catalogs for targets that we pick up on the sonar that may or may not be artifacts associated with the wreck. So these are the shipwrecks that we've documented so far within Lake Erie and also within Presque. We're focusing mainly on the shipwrecks out in Lake Erie. And the next few slides, I'm just going to go through and just highlight some of the differences that you'll see here. Is this centered with the laser?
It is.
Okay, so the 2013 season and the difference between the 2017 season and the quality of the imagery that we're getting. So this is the Charles Foster. It was one of the first, I think it was the first shipwreck that we imaged with the equipment that we're using at DEP. And you can see the difference in the two images. you know, with a lot of distortion and stretching in the image, and then better detail, better contrast that we're picking up in the 2017 image. And as I go through these, you'll see that really play out in a lot of these images. And what's sort of stands out for the Howard S. Gherkin, in 2013, we're getting a lot of interference, electrical interference from the boat, things that over time we've been able to isolate, remove that from the image quality, and you're not seeing that so much in the mosaic image here from 2017. Much better detail that you're able to pick up. And some of the things, like we'll point out later, you get to pick up some things that are in the water, maybe associated with the wreck, but we don't know necessarily what they are. All right. Continuing on, again, another example, the Patapsco, the shipwreck is off of Presque Island, about 25 feet of water. Just highlighting the differences. Really stands out in this image here, the PD Armor. You're picking up details in pieces of the deck that are laying flattened out. Whereas here, you see that there's something there. You know you have a target, but you're not really seeing any detail about what it looks like. So we're collecting these images, S.K. Martin, get them associated with the map that we're going to be eventually putting online. We'll be able to go onto the online GIS map at DEP's website, click on a map, bring up a side scan image of the site, and it also eventually bring up some of the underwater video that we've collected in conjunction with this project. Okay, and again, Susquehanna, just looking at those differences between 13 and 17. Okay, so we know we're getting really good imagery at the sites now. We've refined our techniques, both our collection techniques and processing techniques. So we wanted to set out to do what we're calling contextual surveys. So we're getting the context of the wreck site. What's around it? Are we seeing any other displaced targets around the wreck sites? So we chose the 4 wrecks that you see here, S.K. Martin, PD Armor, the Gherkin, and the Richmond. And we did approximately 1/4 square mile surveys with a towed sonar that you see there. And you're just scanning the lake bottom. You're laying out those lines back and forth next to each other in GIS. You're mosaicing them together into a single image so you can see what the wreck site looks like. We did 2 directional passes on the Martin and the Armor, so we went north-south passes and east-west passes, because as you insanify targets from different directions, you're going to pick up different details or pick up targets that you may not have gotten in one pass. You'll get them on a perpendicular pass. We were only able to get out and do unidirectional passes on the Gherkin and the Richmond, and then the Patapsco, which is also in here, we picked up incidentally doing a survey around Presque Isle, the nearshore area of Presque Isle. Okay, so this is the S.K. Martin. You saw an image of it earlier. You look, the wreck's right there, just a little tiny blotch in the middle. And this is the entire area around the wreck, about 1/4 square mile, that we're able to survey and lay out in GIS. Excuse me. All right, if we zoom in on the wreck a little bit more, you can see there's the wreck here. When we have the raw images loaded into GIS, we can zoom in really closely and get really good detail that we're not going to see here. But when we go through that, we'll scan each site back and forth through them, and we'll delineate targets that we see right in GIS. And we'll plot them up like this. So you can see we're picking up a lot of targets that we're seeing right near the wreck site. We also plotted targets that we saw that were a little bit more displaced. You have a little less certainty that these are actually associated with the wreck, but they're targets that are in the area, so we plotted them anyway just to see where they were. They could have been targets that maybe floated for a while, drifted down away from the wreck and so on. But until you get down and take a look at what they actually are, you don't know that. So we plot them anyway. Here's a wreck of the PD Armor. Nate was with me. We went out and did this scan together. This was the one that we did for the Armor in 2017. You can actually see the north-south lines are plotted right behind it. So we're just looking at the east-west lines here, but they're both layered on top of each other. This is an interesting site because as we zoomed in, we plotted the pieces. We saw this really large feature that was well separated from the wreck site. Don't know what it is. We haven't gotten any imagery of it. But if we zoom in close to it, you can't really tell what it is, but you see what appears to have right angles on it. We don't necessarily normally see right angles in nature. It indicates that this is maybe a man-made origin, may or may not be associated with the wreck, but it's an unidentified target that's in the vicinity of that wreck site. So it's something that maybe warrants a little bit more investigation. Same plot with the Gherkin. We zoom in and we see some targets. Now this is a site that's pretty heavily dived, and in speaking with the folks at the local dive shop that works with us in the past group, a lot of these targets, the closer targets, this is a lot of the, this was a sand dredge. So this is some of the sand dredging machinery that had detached from the wreck when it capsized. But a lot of these other targets, and if I back it up, you can see that that's a sizable chunk of debris. We don't know what that is. There's this line, linear feature that comes off the wreck. We don't know if that's chain. There's something more sizable at the end of it. We actually got down last summer with our ROV, which is upstairs right now if you want to take a look at it during one of the breaks. And we were able to get some video of this. It's completely encased in zebra mussels, so we don't know what's underneath it. We don't know if it's a cable, we don't know if it's a rope, we don't know if it's a chain, and we didn't have enough tether to get all the way out to the end to see what the larger feature was at the end of it. Okay, and that's just zooming a little bit closer so you can see some of those features. You can see there's a pretty sizable target. I mean, if you look at the scale at the end of that, we don't know, we have no idea what it is. Again, with this up here. Okay. Another survey with the Dean Richmond. The Dean Richmond is interesting because it was, they attempted to salvage, what did they think was zinc ingots is what they thought was on that? Is that correct? Yeah. And didn't find any of that, but they did manage to destroy the wreck. It's upside down. You can see that it's completely caved in on the one side from the salvage efforts. But it has substantial debris fields that are on both sides of the wreck. So we can sort of see that in the side scan images, but then we can also find these other targets that are sort of detached from the wreck site, and we can plot those out. And Patapsco, this is the one that we picked up incidentally. It's off of Presque, and you can see the breakwaters that we picked up here in the side scan survey. It's in about 25 feet of water. Again, we can go in and plot the debris targets and get an idea of the magnitude of the debris fields. So there's limitations with what we're doing. We have a lot of error. Error gets introduced from a lot of different areas, one of them being the track error of the GIS that we're using. So when we plot this in GIS, we're taking these images that are drawn out in a straight line, it's laying them down behind us where the boat has traveled. But the integrated the GPS unit for this system is a low-grade system. It's a 10-meter accuracy system. So a lot of error associated with that. We get lateral acoustic error. So you saw some of the distortion in the imagery that we cleaned up between 2013 and 2017. You cleaned up a lot of that distortion. It looks nice, the pictures look better. There's still some distortion hidden in there that introduces new error into your image processing. And then when we make layback adjustments also. So we're towing the towfish behind the boat, the GPS is on the boat. We have to make adjustments for that in GIS when we mosaic the images together. And the way that you're doing that is you're finding two features that cross separate paths and you're just bringing them together. So it becomes an estimation. You're dividing the error between passes rather than really anchoring something to a real control point that's on the ground that you know is accurate. So all of these introductions of error means that when you plot a target that you've picked up on your survey, that's not necessarily right where the target is when you go out and navigate to it. It may not be a purely precise GPS location. But what it does give you is it gives you sort of the geospatial reference all around the wreck site that's just representative of where these targets may lie to inform an on-the-ground study that's going to give you a better layout of the area. And then the last limitation I'll talk about is target size. So when we go out, we're finding echoes of these targets that are on the bottom. We're not going to find anything that's completely covered in sediment. We're not going to see those. But we're also not going to see things, not with the unit that we have, that's really any smaller than about a square foot in area. If you look, this is zoomed in onto a single pixel that we're getting from our sonar imagery. And if you look at the scale, it's about a 5-inch pixel. So maybe 4 pixels together are going to give you a reflection of something that you can pick up and identify when you mosaic everything in a GIS. But generally speaking, anything smaller than that, you're not going to detect it reliably. Not with the system we have. They make more better resolution systems than what we're using. But like I said, despite all that error and everything, it does give you a picture of what the wreck site is, and it can inform the planning for a physical on-site survey of a wreck that you're going to go out and really help to sort of refine those efforts and optimize what you're going to achieve from your survey when you get out there, when you get physically on site. So that's it. Any questions?
So those side scan images are the bright colors, the bright returns, or the harder returns?
Yeah. Okay. So I didn't go into what exactly you're looking at with a side scan image. So I don't know how familiar you guys are with it. It's not a good one here.
Find the one that changes from dark to. Can you go back a little bit more? Because I have a quick question about a particular.
Yeah.
Keep
Yeah.
going back. There. You
Okay.
can go ahead and describe it, and then I'll ask my
Okay.
question.
So you're basically getting a grayscale band back from your sound impulse that you're putting into the water. It sends an echo out. It knows whatever you set your range to, it's going to wait for sound to go out, say 50 meters, and come back, and it's going to listen for any echoes in that time range. Then it's going to move on, send out the next ping, listen to that one. It's going to lay them down and stack them into what is an image if you're traveling along a consistent direction at consistent speed. It's going to give you a brighter reflection, a brighter dot, based on a number of things. So if you have a harder substrate, or a smoother substrate, or you have something that has a greater angle of incidence to the sonar beam, it's going to give you a brighter reflection. So those three things are going to result in a brighter sonar reflection. If you have something that's softer, that's rougher, or that's angled away, it's going to give you a darker reflection. And you're going to get your darkest reflections, and I'll come back to this one, but because this is such a good example. When you have something that has relief above the bottom, you're going to get the darkest where you have acoustic shadows. So just like when you shine a flashlight on something, the light beams can't pass that elevation just to illuminate what's beyond it. The same thing with the sound, and you get an acoustic shadow on the far side of an image. So that's going to indicate relief for what you're seeing. Now you had a specific question about this one here.
Yeah, I'm just curious.
Yeah.
So that was even better. Yeah.
Yeah.
So this is obviously transition from, oftentimes we'd say like muddy to sandy maybe, or an outcrop or something like that. And I was wondering if you knew what the underlying geology is there. Is that sand or is that rock?
Okay, so in this area here, you're seeing softer sediments in this area here, and you're seeing harder sands in this area here. But what you're also seeing, do I closer with that one now? So when we get underwater, on the peaks of these ridges, and I'm not sure about up here, if it holds true up here, but on the peaks of these ridges here are dracaena mussels.
Yeah, so that's probably rock that their muscles are attached.
No, they're actually building off of each other.
Oh,
Is that right? Yeah, but we see them in like almost cornrows on top of these sand ridges. Another instance, another example of that. If I go back to this guy here, all right. So this is the gherkin. It's at about 85 feet of water. It's well ashore. When we get down underneath, we see all this area around here is all soft sediments with like a nice, like almost a reddish algae film growing on top of it. But coming off of the wreck itself is covered, and coming off of the wreck is this sheet of dracaena mussels. It just started on the wreck, anchored on the wreck, started to build a population, and then they're building off of each other and spreading out from the wreck site. So you can pick that up on the sonar, and just as an added thing, when we noticed that we could see the mussels on the sonar, we took that to the opposite side of the state. And over the past couple of years, we've been doing surveys in the Delaware estuary to see if we could map the freshwater mussel populations. And we're having fairly good results with that too. So, yeah.
Just so I can imagine is how fast do you drive the boat when you're taking these images, or do you have to be still?
No, you have to be moving. Ideally, we seem to get the best imagery at about 3 to 4 knots of speed. So you're moving pretty slow. If you're doing, quarter mile at a time. You can imagine it takes, each one of those takes a fair amount of time to lay out. To do one of these quarter square mile efforts, travel out, travel back, set up, tear down, is about a day's effort to do the survey. And then you're looking at additional time during the processing.
So once you've got the kind of broader debris field characterized, could you go back then and travel the site at different angles and get better resolution on your imagery?
Not really better resolution, but when you're sonifying the targets from different directions, you might see more or less detail based on what angle you have on the target. Yeah. Well, we'd like to get better equipment going, Susquehanna would,
Great.
Okay.
Thank you very much. And thanks to all of our speakers. This concludes our session for today. Any other announcements?
If you were a speaker in this session, Eric is going to take a still picture of you out there in front of the Presque image. I'll show you.